Well, good morning, everybody. My software says that I'm live now, but you can't talk to me directly, so you have to just enter things in the Q&A if you want to say something that I'm going to read. Thanks for joining this discussion today on safety and high-power rocketry. I realize that I am competing with Jim Barrowman and a presentation on GPS, but I would be surprised if I had a lot of people real-time, but everything's being recorded. And so after the fact, people can come back and watch the things that you couldn't watch real time because there were two things going on at the same time that you wanted to see both. You can, the way this NARCON is being run. Over 520 people involved in this NARCON. This is a fun event. So I'm a high power flyer. I've been an NAR member for 58 straight years. I'm not a born again rocketeer. I never left. I certainly fly high power, but I fly every other kind of rocket, always have. I was NAR president 2008 to 2012, and right now I'm the NAR's representative to the National Fire Protection Association Committee on Pyrotechnics, which is the committee within that organization that writes the national codes and standards for fire marshals for the safety of things that have the provide risk to people or risk of creating fire. So these are actually the governing codes in a legal sense that dictate safety for our hobby. So I'm proud to be our representative to that committee, and through that process, we write essentially the safety regulations that become safety code for the organizations NAR and AAA. My background is, in addition to rockets, model rockets, I have a degree in aero engineering from MIT and a double master's from the Naval Postgraduate School, a 41-year career in the Navy, which is now behind me. And I want to talk about safety, but certainly because of my background in the Navy, I have a pretty good background in safety. I handled nuclear weapons there. There's a little bit more safety precautions for them than our rockets. I've also been a range crew member for the NAR range crew that runs the NASA student launch program launches, and that's a NASA-run program, which, as you can imagine, has very rigorous safety requirements. And some of the lessons learned for how you enforce safety, I've learned through my participation in that process. So let's talk about safety a little bit. I'm going to talk about 5 topics. And as I go through here, I'll be reading the Q&A box. So if you have questions real time, I will do my best to try to answer them real time, or will answer as many as I can at the end. This session doesn't actually end at exactly 11:55 Eastern. It will continue to go on, so I'll stay here for a few minutes afterwards. If you need to shift to other events at that time, please do. So here are the 5 topics I'm going to talk about today, one at a time. So we are an activity that slings around a lot of kinetic energy and deals with devices, rocket motors that create a lot of heat and release a lot of energy chemically. So, bad things can happen. When you sling around that much kinetic energy and you light big old rocket motors, if you're not paying attention and you don't do all the right things, unfortunate things can happen. Here's a couple pictures of unfortunate things that have happened and been documented, ranging from, lawn dart impacts of 50-plus pound rockets right near people who never saw it coming, range fires, somebody touching a power line and getting electrocuted, and, damage to property that nearly killed people. We have not killed anyone with high power rocketry. However, we have killed one person with model rockets. I'll talk about that in a minute. So if you're not paying attention and you don't do the right things, bad things can happen. They just are. We don't pay for NASA quality control, and so sometimes mistakes happen. The key is making sure that the consequences of the mistake hit the ground far away from people. If you can at least do that, then we're going to have a good safety record, and you just have some broken rockets to clean up. And so that's really the goal of what we're trying to do here, to try to not let bad things happen, but when they do happen, make sure they happen somewhere else, far away from people and valuable property. So what's the risk history of our activity? Well, in this hobby, model rocketry and high power together, there have been at least 5 fatalities in the past 20 years from people who didn't apparently read, know about, or follow the safety code and tried to get a rocket off a power line. None of these happened under NAR or AAA insurance at one of our launches, but they happen. The safety code prohibits it. If you are aware of the safety code and you follow it, this would never happen. Not everybody follows the safety code or even knows what it is, particularly in model rocketry. In high power, you are typically in a more structured environment. Range fires. When the rocket lights, the ground around it will light too if you're not paying attention. And if the rocket were to land sooner than it was supposed to and the ejection charge goes off after it hits the ground, you can have a fire at the landing spot. And a range fire is something that has to get put out. Usually it expands pretty quickly beyond the capacity of the local launch organizers to put out, and fire departments called. And at that point, you have lost the launch site. So that's bad. Launch sites are hard to come by, and if you light them on fire, you're going to lose them. So we don't want to do that. And then there's the possibility of damage or injury by rockets almost exclusively on the return path, ballistic, or even landing with a deployed recovery system if it's a very heavy rocket. Far too often we drop rockets on cars or drop rockets on buildings, even under recovery. That's not good, particularly for high power rockets that are very heavy. You don't want to do that. Strikes on people. We've been lucky so far with high power rockets. Just to be clear, if a high power rocket strikes a person straight on, they're dead. There's no two ways about it. There's no way to not be dead if you're hit with that much energy. There has been one death from a model rocket. That was not on an NAR range, and it was not covered by our insurance. We have heard about it. It was essentially a long dart that hit someone in the head. There have been injuries, grazing injuries from high power rockets, but no straight on impacts. And there have been a number of people who got burned from inadvertent ignition of the motor. When they hooked up the igniter on the pad, it lit for whatever reason, or inadvertent ignition of a deployment charge while they were loading the rocket with the recovery device. So those are the kinds of risks that have occurred. The most common being damage to property and lighting the field on fire. None of these are good. So how do you not do that? So let me see if I can page down on my slides. So how do you keep bad things from happening? That's really the goal. That's what safety is all about. Sometimes they're going to happen. You can do a lot of things to minimize the probability, but we'll deal later in the discussion with what do you do to make sure that if they do happen, injury and damage doesn't happen. We have a great safety record in this hobby, relative to, like, for example, football, which everybody wants to play in school, in which people suffer life-altering injuries at a very high percentage rate, but it's okay. We don't want injuries to happen in the hobby because even one of them is not going to be okay. People are going to remember it, and it could have an impact on our hobby's record, our hobby's insurability, and even on our ability to have a hobby at all. So the key to keeping bad things from happening is to follow the safety code. It was written by experience. I wrote a good part of it. The revision of the model rocket safety code that was done long after the version Harry produced was one I did, and I contributed to the high power safety code. And the NFPA committee that I belong to is responsible basically for establishing the requirements that we simplify and put in our codes. Those codes are designed to minimize the risks. They only work if you know what they say and do what they say. And another way to minimize risks when something bad happens, which it will from time to time, carefully laying out the launch site and operating the launch in the proper way will reduce the risks if something bad should happen at your launch, despite the safety code. So we had a run of really scary accidents back in the first decade of this century, and the NAR asked Dr. J. Apt, who was a space shuttle astronaut, flew 4 times, to do his thing, do his professional thing as an astronaut and a PhD, and have a look at the data and look to see what the root causes were of the safety incidents that had been happening, and give us some advice on what we might do to get after the root causes of those safety problems. He did a fine job, as you would expect a Harvard PhD and an astronaut to do. Very systematic. Collected a lot of data from flight reports that had been kept by NAR sections, and from that data, and those are mostly model rockets, but there were some high power in there. But I think the same lessons scale to both types of rockets. The consequences are higher for a big, heavy, high power rocket. The average flight failure rate was 8.5%. And no surprise, rockets that had multiple motors in them, called complex, stage, cluster, were twice as likely to fail as simple rockets. And 3/4 of all the failures were recovery system failures of various kinds. So that really became the focus. It's recovery that's the problem. The safety code, the safety certification of rocket motors leads to a very small percentage of them blowing up, very small. And the standoff distances we follow make the consequences when they do blow up not a safety problem. It's really the recovery that's the key issue here. Sometimes an unstable flight, but mostly it's recovery. The key areas of concern that we need to get after are ballistic impact, lawn dart outside the launch area and near people, burn injuries from inadvertent ignition, and grass fires. Those are the areas of concern he identified. I've already mentioned that was the areas of concern, but the reason they're areas of concern is that we had real data that said they should be the areas of concern. Here's the data. And this is a pie chart that shows the failure modes of 6,169 flights, of which 523 had a failure problem. A couple of NAR sections were obsessive about keeping data and provided that data to this study. It was very valuable. So you can see the powered flight phase, the upper right there, motor CATO, motor unrestrained, shred, unstable. Those were 1/4 of the failures, and all the rest were failures of recovery. Separation, where 2 parts came down that should not have come down separately. No parachute. Nose came off, no parachute. Lawn dart, which is the nose didn't come off. And core sample, which is the nose came off, but nothing came out, so it took a core sample with the tube hitting the ground vertically. 3/4 of all the failures were recovery failures. So that should be the focus, to make sure that those don't happen. So we'll talk about that. So I'm going to step through a couple of sections here, and I'll get to the how do you prevent recovery failures and prevent them from being a problem in later sections. The first thing I want to do, though, is talk about sharing the sky. And just to remind, you don't own the airspace. The FAA owns the airspace of the United States outside of military bases, and they have a set of rules, the Federal Aviation Regulations, that cover everything that goes on in the air and how they regulate it. There's a particular part of it that covers amateur rocket flying, and what we do is called amateur rocket flying by the FAA. High power rockets, under their definition, are Class 2 amateur rockets, and Class 1 would be model rockets, which do not require any prior authorization to fly. You have to, I won't talk about that, but that's not a big deal to fly a model rocket if you do it safely and not near airplanes. But for Class 2 amateur rockets, high power rockets, you need to get permission to use the airspace in advance from the FAA. That's called a waiver, and it's issued for a given place and time. It provides your ability to share the airspace. It does not give you exclusive use of it. It simply notifies airmen through a notice to airmen that rocket flying is occurring in that area, and they should but do not have to stay away. FAA is not going to give you a waiver for a piece of airspace that includes an air lane, an air transportation route. So the upper limit of your waiver altitude will be dictated by where are the air traffic lanes in your area. And if there are a lot of air traffic lanes around and they're at lower altitudes, you won't get a very high altitude waiver. If you're at Black Rock, you can get a waiver to orbit, basically, because there's no air routes that go over there. So it just depends on where you are and what the air lanes are around you. So you're given a waiver which gives you permission to share airspace for a period of time up to a certain altitude. You file for a waiver in advance, 45 days or more. There's forms involved. This is on the NAR website. You can now get a waiver for an extended period of up to 2 years, and it can be every day for a straight period of up to 2 years. And you just activate it by making a couple of phone calls. That's your dream waiver. My section, Novard, tried that, and we got it for every day, but only for 1 year. Our local region would only give it to us for 1 year. But still, we have a waiver for every day, so we can activate it any day that we need it. We can call in, go through the process, and get permission to fly. So go to the NAR website for more details, but as I mentioned, the FAA is not going to give you permission to use airspace that airlines use on a scheduled basis. They may give you a window of opportunity to fly to a higher altitude than your general waiver, But if they do that, you're going to have some means of real-time communication with FAA air traffic control. That's kind of hard. So when you do a flight, the waiver will say that you can do it under certain conditions. You can't create a hazard to people, property, or airplanes, can't fly into clouds or at any altitude, to any altitude where the cloud coverage is more than 50%. Pay attention to this one. People frequently don't do this. You cannot fly through clouds. You cannot fly really through a blue space in the sky if there's more than 50% overcast. You can't fly between sunset and sunrise unless you get a specific authorization to do so. This is not true for model rockets, by the way. You can't fly within 5 miles of an airport unless you're specifically authorized. And there has to be an RSO in charge and fire control measures available. So high power rocketry is inherently an activity that's done in a group setting with the formal range safety officer appointed, and a little bit more procedural requirements than model rockets. And you do have to phone in to TRACON and to any control tower for a nearby airport at a certain period of time in advance so that you can have the waiver activated and a NOTAM published. That's how you share the sky. If you don't get this right, we will not be allowed to share the sky. So don't foul this up. So I mentioned that the key factor here is to keep your rockets from impacting people who are not aware that they're coming and have no opportunity or time to get out of the way. If you're not paying attention, your rocket can outfly your field. Your launch site is not the little piece of dirt you fly from. In the terms of the safety code, the launch site is where your rocketry activities occur, including the landing of the rocket. So you're not supposed to land your high power rockets outside the periphery of the property within which you have permission to fly. So this is a picture here of Johnson Space Flight Center, where an NAR section had a few of their rockets land over in a NASA antenna farm, and they were told to go away and come back when they could prove that they knew what they were doing to NASA standards. So this is a splash computer run that shows where rockets will land. On the left, if you do apogee deployment with a particular high power rocket to half a mile, with winds varying from direction and speed, the little dots show where the rocket will land under those conditions, apogee deployment, and some of those landing spots are in the middle of buildings, NASA buildings, not going to work. If you fly to a lower altitude or you use dual deployment, which occurs at a lower altitude, then on the right, your dispersal is much less and all of your flights land in the assigned launch area. So the lesson from that is if you're flying on a windy day and you have a restricted launch site, BlackRock not being one of those, but most of us don't operate there, control your altitude, not up to the waiver, but up to the altitude beyond which, if your rocket deploys a parachute, it will drift outside the field. And if your rocket drifts outside the field, do something about it. Either require that henceforth people must use dual deploy to cause their deployment to occur at a lower altitude, or reduce the altitude to which people can fly. But don't land your high power rockets outside the bounds of your launch area. Because outside the bounds of the launch area, people don't know what you're doing. May not know that you're there. And suddenly, plonk, some big heavy thing lands, either ballistically or under parachute. You don't want to do that. You don't have permission to do that. You can't. So you want to keep spectators safe. So this is an impact splash pattern of impacts either ballistically or by recovery systems. So ballistic flights rockets tend to arc into the wind. So the wind is from the upper left here. It's diagonally across this from upper left to lower right. So your ballistic flights are going to arc into the wind and no parachute will come out and they'll just come straight down. So they'll go upwind and land with tremendous velocity someplace upwind. And the ones that open the parachute will go downwind. So you can see the splatter pattern, all the red dots of them. Where do you want to put the spectators? Well, not upwind, not downwind, but crosswind. And so if you're paying attention to wind direction in your range layout, then you position the spectators in a crosswind position. Now, you may be in a launch site where you don't have a lot of alternatives as to where you put cars or people. So what do you do in those cases? Well, you could not fly. So if you're dropping big, heavy rockets on the parking lot, stop it. Don't fly. Change the launch angle, move the cars, reduce the altitude at which deployment must occur, or don't fly. But don't keep dropping rockets onto the cars and hope nothing happens. And you can predict where they're going to go based on the wind direction. So this is something that you really need to pay attention to based on conditions of the day and the circumstances of your launch site field. So this is the ideal launch site layout, where you have the red circles there are the standoff distance that everybody must be away from the pad at the moment of launch. The ellipses show the splatter pattern of rocket landings, either ballistically upwind or somewhat softly downwind. Shows you where the spectators go, which is outside those ellipses. And the pink illustrates the 1,500-foot exclusion zone, where you're not allowed, there cannot be any inhabited buildings or any public highways, which is roads with, I think, more than 20 vehicles per hour going on them. So the access road to your launch site is fine, but a highway is not. So these are all the things. These are on the NFPA code. So this is just how you thoughtfully go about laying your launch site out. Now you can put the launch pads at a place that's fairly far upwind so that you have maximum opportunity for the rockets to drift downwind without exceeding the boundary of your launch site. So if you have flexibility as to where you put the launch pads and where you put the spectators and cars, you can play with those based on wind conditions of the time and lay out the site in such a way that you have very little risk that when something bad happens, something dangerous results. You don't want that to happen. One other thought is efficiency. So, typically a rocket range, if you're not thinking about it, will be laid out like the one on the left. At 30 feet, you have the model rockets up through F power, 100 feet, HI and J, 200 feet, K, and complex others, and then beyond that, M's, L's and M's. If you do that, then when any pad is loading, every pad has to stop. Or when any of the big pads are loading, everything inboard of them towards the launch control area cannot be loading because you're too close. If you do what's shown on the right, which is put the model rocket pads 30 feet out, and then the first row of high power pads 100 feet beyond that, technically you could fly the high power pads while still loading the model rocket pads. You do have to pay attention to where people are in their path walking out to the further pads or out in the field walking rockets back after recovery. But you can get a lot more efficient throughput if you lay the range out as shown on the right. Fires should be prevented, but if they happen, and sometimes they're going to happen, particularly you can control whether a fire happens at the launch pad by doing what you're supposed to do around the launch pad, what's in the NFPA code, which is use a blast deflector and totally clear the area near the launch pad, strip it, denude it. If you can't completely do that, then you can lay Nomex pad blankets out. But there is a specific cleared radius within which you can't have dry grass or anything that's burnable. And that radius is increased by 50% for sparky motors. You can use pad blankets. You do need to hold them down because the rocket motor will pick a pad blanket up and sling it. But if it's too dry, don't fly. If there's a fire ban in effect for your county or your state due to burn conditions, fire ban means model rockets and high power rockets cannot be flown other than with of the fire marshal for that jurisdiction. So, pay attention to the news, and if there's a fire ban, this means you. So the real risk, I think, for fires, if you're paying attention to the area around the launch pad, the real risk is the rocket crashes, whatever. The ejection charge goes off on the ground, and something catches on fire there. It's downrange. So you need to have something available, the appropriate stuff available to deal with it. Your tennis shoes are not a good solution. Water is the best fire extinguishing agent. Pressurized water is the best thing to have available. Flappers, big sections on pole, for example, are a great way to beat out a grass fire. But you need to have that equipment available, be ready to use it. The fire extinguishers don't work if you don't put water in them, and I've certainly seen that a few times where there's my fire extinguisher. Well, it's pretty light. Do you have anything in it? Well, no. The code means have a fire extinguisher that has the fire extinguishing agent in it. So please do that. And if a rocket crashes downrange, get there in a hurry. Run there quickly and expect to find a fire when you get there and be prepared to deal with it. Okay, let's talk a little bit about prevention, which involves inspecting the rockets. I'm not going to give you the whole tutorial on how you do a pre-flight safety inspection. I'll just hit a couple of the really key points in what you really need to be looking for. Safety check-in is the most important range crew position at a high power launch, probably at any launch. If you have people who are more experienced, it's more important to have that experienced person at safety check-in than it is as RSO. You'd like experienced people at both, but this is the key one, because once the rocket's out on the pad, all the RSO can do is say whether it can fly or not and whether the launch angle is appropriate. Those are important. But all the details that you can go through to make sure that the rocket is likely to work are done at safety check-in. And you need to empower the person who does this so that that person can say no. If someone's rocket is not safe, you don't put it on the pad and say, this is a heads-up flight. You just don't fly it. You need to have them have the tools they need, which may include scales, for example, and some clear guidance on the procedures and the support of the club if they make a decision that something just is not safe to fly and can't fly. There should not be any appeal there. And if there is an appeal, you can have a reasonable discussion, but if you override the person who has made the safety judgment just because you want to see it fly and so is flying, it's a good guy, good gal, that person is no longer empowered and you may as well remove them. So this is a really important position, and you can't be worried so much about people's feelings. Well, this is easy for me to say after 41 years in the Navy, where I'm used to telling people, what to do. But this is really important. So you do not have a right to fly. It's a privilege. You have a right to fly safely, but you don't have a right to fly anything you want. And so we have to make sure here at Safety Check that the rocket that's going to be flown is safe. You need to make sure that the motor is a legitimate motor with, it's on the certification list. Funny story here, in TARC, of course, we're dealing with young people who are not necessarily experienced rocketeers. Many of them are flying reloadable rocket motors. So we've had people attempt to check rockets in who had a certified motor. It's a Cicerone motor, and they took the Cicerone reload and put it in the motor mount. They didn't realize that a casing had to go around it. So anyway, so you have to ask questions. If the person who's presenting the rocket is not highly experienced, you may ask more questions. Don't assume anything. As a high power flyer, they should be certified, or it should be a certification flight. So you need to verify that if you don't know this person and their certification status, have them show you their card, NAR or triply. Thrust to weight ratio is important. So there's not a hard and fast rule here, other than NFPA does have a hard and fast rule of a average thrust to a rocket weight ratio must be at least 3-to-1. That's in the NFPA code. Typically, we're looking for 5-to-1, but what you're really looking for is a motor with enough thrust to get the rocket off the end of the launch device, however long it may be. And if the rocket has a lower thrust motor, the launch device can be longer, should be longer. But you want it to get it off the launch device with enough speed that if there's any wind, it won't weathercock to an unsafe angle in the wind. That's really what we're doing this for. You need to make sure that the motor is restrained properly. And another important one, if anybody is using motor delay and motor ejection on their high power rocket, I've quit doing that because I don't trust them. But if they are, you need to make sure that the delay time is appropriate to the weight of the rocket so that the delay is likely to go off at apogee and not 7 seconds after apogee when the rocket's coming down at high speed. So what are you looking for? Well, remember the 75% of failures are due to recovery system, and when the rocket is presented at safety check-in, the recovery system is packed. So you don't quite know what's inside. So you need to have a conversation with the person about how they did it, what's connected to what. Better yet, a peer review of somebody else who has looked over their shoulder as they were doing the packing to make sure that all the snap links or all the quick disconnects were screwed together and everything else is connected properly. Some of those things that might be problems in recovery are detectable and preventable. Drag separation of a heavy nose cone at burnout, for example. Friction fitting nose to body, or two sections of a rocket body together for a high power rocket, is a really, really bad idea. You just shouldn't do it. It's not a safety code requirement that you cannot, but I sure wouldn't ever let somebody fly a high power rocket that's using friction fit to hold two body parts together. There's just too much energy going around in those rockets for that to be reliable. Shear pins. The harness system that connects the rocket together for recovery should not use non-forged eye bolts, ones that are just bent over. Those are the ones you get at Home Depot. So what bends them over can result in their unbending. So I've seen them straighten right out after an ejection at a high speed. Should not be using elastic in high power rockets. That's useful for clothing and model rockets, but not high power rockets. You use plenty of nylon or Kevlar shock line. Kevlar has no give to it, so those need to be longer. The electronics is hard to figure out. Malfunctions of electronics are usually user-induced, and it's impossible to inspect that really at check-in. So you're going to have a conversation with the flyer about what's supposed to happen in flight and where. If they don't know, then it may be time to start taking the rocket apart there at check-in and looking at things. If the person does not know answers to questions about recovery system, how it's packed, how the electronics work, then you really need to take them aside and just make sure everything is right. You definitely want fresh batteries that aren't just masking tape to something, but are permanently secured. Poor packing of parachutes or incorrect rigging of the deployment sequence will result in tangles and crashes, and inadequate pyrotechnic charges for deployment. Personally, I always use way too much black powder and just a really long shock cord because I do not want the rocket to not come apart. When the ejection charge goes, my rocket's coming apart, and usually with a loud report. So I use fairly robust pyro charges. Pyro charges and upper stage igniters need to be E-match types. So I have made this mistake where I tried to use an Aerotech igniter for the upper stage of a two-stage rocket on my first attempt at two-stage with a 9-volt battery. And that didn't work. That was embarrassing. So anyway, pyrotechnic charges need to be robust, and the igniters need to be low current, or there needs to be a separate battery that can feed them lots of current if they are a higher current version. So stability is always a concern, but as I mentioned, the probability, the frequency of occurrence of instability is fairly rare. So you can certainly use simulation tools to determine the center of pressure of a rocket. And your high power flyer, if there's any reason to think that the rocket might not be completely stable, CG-CP relationships doesn't look right, then have them prove to you where the center of pressure is by calculation. Then you can just pick the rocket up and balance it on your arm and verify that the center of gravity is forward of that by one or more calibers. Stability is also influenced by the launch device. So if you're flying a high power rocket on a rod, you must have never seen any of the launch videos where they take a video from underneath the rocket on its way up the rod. You can see launch rods whipping around from their springs basically, and they whip back and forth as the rocket approaches the top of the rod. And when you see that dynamic in slow motion, you realize that a rod is a really bad idea for a heavy rocket. So you should be using a rail. And the rail needs to be on a launch pad base that doesn't wobble or move sideways. When the rocket motor, remember the rocket motor is on the side of the rail. When that rocket motor lights, it kicks the rail. And if the rail isn't rigid, it kicks the rail in the opposite, downward in an angle in the opposite direction from the side that the rocket's on, which would lead to a launch departure angle, different from the one at which the rail was set. I've had that experience, and I had a bad flight that the ejection didn't go off, and I crashed a rocket near people. And it was all because the base on which the rail was mounted was not sturdy enough. And let's see, you need to put the right angle on the launch device. So remember, the rocket's going to weathercock into the wind, and you want to aim it a little bit downwind if you have the flight go, if you want the flight to go straight up. And you may, because of the direction of the wind and where rockets have been going and landing, you may want to put a crossways angle on the launch rail, slanting it to the side so that the trajectory it's on when the recovery device comes out does not result in it drifting towards cars or people. A couple of key points on physical inspection. The upper left there are Home Depot eye bolts. that were bent, and they came unbent in the force of flight. And the right-hand side there is the U-bolt that was used to anchor the recovery system that ripped right through the plywood bulkhead that it was mounted to, because it was 1/4-inch plywood, which was not thick enough to take the shock. So these are things you can physically inspect and make sure people aren't doing that. This part is fairly straightforward. Is the motor secured in the rocket? No one should be friction fitting a high power motor into a rocket. There should be a positive retention device of some kind. There are many different brands and approaches. But the rocket motor, the objective is to have the rocket motor stay in the rocket throughout the whole flight. And if the rocket flyer is a beginner, you might want to make sure you understand how the rocket motor is going to stay in the rocket going up. That it's not going to fly through the rocket. High power reloadable casings have a lip on the outside, so the motor mount system should take care of that. Single-use motors may not, so it's a question to ask. And finally, is the recovery system big enough to keep the rocket coming down at a reasonably safe final descent velocity, which may be after the dual deploy or maybe after the Jolly Logic chute releases, but something around 20 feet per second is a typical safe landing speed. So you typically use a drogue at apogee in a delayed deployment of the main, because if you're coming down at 20 feet per second from 6,000 feet, you're drifting forever. And as I mentioned before, don't friction fit, shear pin. Let's see. So operating the range, a little bit of procedural guidance here. So the RSO under the NFPA codes is the single person responsible for ensuring that everything happens safely. There is no right to fly, there's a duty of safety. So it's okay to say no, and it's your job as RSO to say no if something is not going to be safe. If you think it's not going to be safe, saying this is a heads-up flight is not the right answer. Don't fly this rocket is the right answer. And if something happens on the flight that didn't work out, that it turned out to be unsafe, well, stop and figure out what just happened and do something to make sure that you correct the procedural failure that led to that, or the launch rod, the launch rail angle that led to that trajectory being really unsafe and the rocket drifted towards the crowd. Do something. Don't just watch a bad situation happen and then hope it doesn't happen again, but don't do anything to change it. That's just not how you do safety on a rocket range. And we're all guilty of this when we're RSO. You get launch fever, so you're focused on the next flight and you're not paying attention to everything around you. You get tunnel vision and you don't look at the sky enough, and there's an airplane coming and you never saw it, or somebody's crossing the range in a place too close to the launch pad and you didn't see it. So it's just, you need to slow down. When you're launching model rockets and you're trying to get one off every 30 seconds for a bunch of kids that are all A motors, that's one thing. If you're launching rockets with high power motors in them, just slow down. Don't get that launch fever. I mentioned the importance of safety check-in. So under the NFPA code, high power rockets must be checked in, or the range must be operated by someone who's high power certified. It doesn't say you have to be certified at the same level as the rocket you're flying. Our practice, I think, in the NAR and Tripoli is that's what you want to do. A couple things on launch pad safety and control. So test every pad before the launch to measure the firing battery charge, make sure that the battery is going to work, clean the clips and rails, and do all that stuff. Make sure that the launch system is electric match safe. A lot of people are going to be using E-match type igniters, or igniters that will go off on fairly low current. Most launch systems these days are safe. Do not do continuity check with enough current to ignite an igniter. But if you're using an old launch system that used the incandescent bulb technique for showing you that there was continuity, an incandescent bulb will allow enough current through it to cause an E-match to go off. So old launch control systems were guilty of this. Modern ones typically aren't. There should be a way to disconnect the pads from the launch system or de-energize them, positively de-energize them, to make sure that when you approach a pad to load it, you, the flyer, are absolutely certain that there's no energy going to those clips, no way that any energy could be going to those clips. And certainly it's bad practice if you have a row of pads or a whole bank of pads. None of them should be flown while any of them are being loaded. just in case somebody back at the launch control gets some switches confused. You don't want a pad flown that was not intended to be flown, and if there's anybody at that pad. We have a requirement anymore that you minimize the number of people out at the pads when loading. No spectators, no children, no family members. This is for high power, right? So we're not talking model rockets. None of these are true there. But for high power rockets, there should be only a couple people out at the pad and no children, no family members, nobody, no spectators, just people who are directly, actively engaged in getting the rocket ready to fly. Of course, you don't connect the igniter or turn on your recovery system electronics until the rocket is vertical on the pad. And then make sure before you fly that people who are returning their rockets from previous flights are not anywhere near the pad as well. The launch standoff range applies to everybody. Photographers are not exempt. I mentioned earlier that you want to angle the launch rails to make sure that the flight path points away from the crowd and that the rockets land only within the launch site. So if you overfly the spectator or parking area on recovery, if rockets are drifting over those areas, stop it. Do something. Change the launch angles and inspect that that's being done, or just don't fly. But don't keep flying rockets over the heads of people. You're supposed to have a PA system. You're required to have a PA system that can be heard by everyone in the launch area. Don't overuse it. Don't call heads up for everything so people won't listen anymore, but be able to call heads up when you really need it. If something lands on a power line, call the power company. That's all there is to it. Call the power company. No, and under no conditions whatsoever do you try to go get it yourself, even if it's hanging down low. In fact, if it's hanging down low, you better call the power company right away so no one's tempted. So this has been kind of a long talk. I wish we could talk back and forth by voice, but we can't. Safety is important. Our society has a lot of lawyers in it, and they make their living by lawsuits, and you don't want to give them anything to create a suit from. One of my personal goals is to make sure we have more people go be aerospace engineers that would have otherwise been lawyers. But in any case, there's a lot of lawyers around, and you just don't want to do anything that would cause a lawsuit to occur as a result of somebody is injured or somebody's property is damaged. That's something we can control. If you are a responsible rocketeer, you understand the risks, you understand the safety code, you understand the requirements, and you make big person adult decisions about whether you fly or don't fly and what can fly, we have a safe activity and it'll stay safe. The energy levels of our rockets in high power rocketry make safety incidents really dangerous. So you just can't let them happen. So it's our job within our hobby. We're self-policing to make sure that the safety of the hobby is preserved. And hopefully I've given you a little bit of guidance here on how you might do that. I'm going to go over to the question and answer now and see what I got over there. I've been kind of monologue talking. So results about the 5-to-1 versus 3-to-1 thrust to weight ratio. So there is no hard requirement for 5-to-1 thrust to weight ratio. In high power, there's a requirement for at least 3-to-1. It's a good practice to be looking for 5-to-1. But as Steve Loveliner said in his column in the E-Rocketeer last month, you can fly rockets that aren't 5-to-1 based on their average thrust across their whole burn time if they have a good high initial thrust. But then you really need to go into your flight simulation software and make sure that because the rocket motor, while it may have a low average thrust, it has a high initial thrust. You need to make sure that it comes off the pad with sufficient speed, velocity to be safe in a crosswind. So you can determine that from a flight simulation. So we have not chosen to put some kind of blanket requirement for 5-to-1 because there are pathological cases where the rocket's perfectly safe even with a lower thrust to weight ratio. Radio control rocket gliders, I mean, some of Frank Burke's stuff, it's safe because it's under control. There's things you can do to make sure that it goes up safely. So we haven't applied a hard and fast rule there. Okay. Boy, there weren't a lot of other Q&As over there. So this someone did ask about a copy of this presentation. It's on the NAR website. Go to the NAR website under safety, and you can look at the posted resources there. And this version of this brief was just put there yesterday. There has always been a version of this brief there, at least for the past many years. And there are a lot of other resources also on that page of the website. So we've summarized or gathered together all of the safety resources to give you the best advice we can on how to keep your hobby activities safe, and put them all on that one page. There's reference material there that you can download and use with public safety officials. The NFPA codes themselves are not there. You can view them online, but you can't download them because NFPA pays their bills and keeps their organization afloat financially by selling copies of their codes, either retail one at a time or by subscriptions. They're pretty expensive, $35 or so. But you can read them on the screen. And if you follow our safety codes, which were derived from those, you are by that following the NFPA codes. But your fire marshal will not have heard of our safety codes. He will have heard of the NFPA codes. So if you have a discussion with the fire marshal about whether this is a safe activity and he should permit you to do it, you can refer him to those NFPA codes, which he typically has. And that's where he finds his resources that he trusts. So let's see what else I've got. Not too many questions. I bet everybody's over watching Jim Barriman. So let me see. I have more people than I thought I'd have. I'm personally going to go watch Jim Barriman's presentation at a later time. I'm really jealous that he's doing this at the same time. But because we're recording all of these, anyone who is registered for NARCON will be able to continue coming to the NARCON site after the event and just go click on the presentation that you wanted to hear but didn't, and it'll play back for you. So, okay, let me go back to Q&A, see if anything else has popped in. Wow. Not too much else there. So anyway, I hope that in the club that I'm in the section that I'm in, we do a range safety presentation once a year where we go through something similar to this for what should we be doing at check-in, how should we be running our range, because we need to remind ourselves on a yearly basis, on a regular basis, that this is the right way to do things, the safe way to do things. This year we did something a little different because going through the same brief, every time is sort of boring. We each told stories. What experience had we had that was terrifying, and what did we learn from a safety perspective? And what did we learn from that experience about how we looked at things going forward? And what did we change about our pre-flight preparations or safety inspection as a result of the scary thing that we had happen to us? That was pretty interesting. We've all seen scary stuff. Wow, hey, Zoran Pelagic is the head of FAI International Hobby Rocketry is online with us. And sure, Zoran, I could make a version of this. It would not be the same as this. As you know, Zoran, I produced a proposed safety code for FAI International Competition Rocketry, but I could certainly do a presentation on that. Different presentation, happy to do it. You and I can talk separately. So let's see. Welded eye bolts. Well, welded eye bolts are better than bent eye bolts that aren't welded. Forged eye bolts are the best. But a bent eye bolt that isn't welded is a really, really bad idea. So don't do that. There was a TARC question on here somewhere. Please see the TARC question. Ken Blade asked for a TARC-related question at the bottom of the scroll, and I can't find it. So anyway. So any of you that want to talk to me separately, individually, I can do that by email. I can be reached at nfpa@nar.org. That certainly works. That goes directly to me, or my personal email address. I think many of you already know that. But nfpa@nar.org if you don't know me and don't have my email address. I'll be happy to deal with your individual safety questions. I am not the safety committee chair for the NAR. Steve Lubliner is. He's also a member of the NFPA Pyrotechnics Committee. So safety@nar.org would also get you an answer that would be Steve's answer. We usually answer questions the same way. Steve did safety stuff for professional missiles for Raytheon. Let's see, what else we got? I don't see any other questions on there. So with that, I will conclude this presentation and thank you for your time and attention. And if you think it's interesting enough, tell other people to watch it after the fact. And I'm going to switch channels and go watch what Jim Barrowman did. So have a great day, everybody.